We now evaluate this integral of f of x dx from x equal to 1 to 13, and we see that this is approximately equal to area under the curve of f of x, under the curve of f of x from x equal to 1 to x equals 13. So how do you find this area under the curve of f of x? That is, we have to calculate the area under the curve of f of x from x equal to 1 to 13. For this, we are given that three sub-intervals. So we are going to use these three sub-intervals. For each of the sub-intervals, we are going to calculate the area of the rectangle within that sub-interval, and add them up together. So let's see how to do it. I'm going to consider the first sub-interval, that is 1 comma 4, and we know that the area of rectangle is width times height. This is the general formula to find the area of a rectangle. Width times, see that this is height, it's not a length. And so let's calculate the width of this rectangle defined within this sub-interval. The width is the x2 minus x1, the difference between the x coordinate. So here it is 4 minus 1, and this equals 3. So we say that the width of this rectangle is 3. And to determine the height, we have to evaluate the function value at the right endpoint. So here 4 is the right endpoint. So we say that the height of this rectangle is f of 4. We can find f of 4 from the table. Let's look at the table. We see that it is 17. So therefore, the area of this rectangle equals, this is 3 times of f of 4 is 17. Let's calculate this. This equals, I plug it in the calculator. This is 51. So we found the area of the rectangle for the first sub-interval 1 comma 4. So likewise, we have to find the area of the rectangle for the other two sub-intervals. Let's do that now. I'm going to consider the second sub-interval, that is 4 comma 9, and here I have to calculate the width and the height. The width is the difference in the x coordinates. So we say that it is 9 minus 4, and this equals 5. So we put 5 here, times the height is, so we have to consider the right endpoint. So it is f of 9. And this equals 5 times. F of 9 is, we can see from the table, it is 26. So we plug in 26 here. And this gives 26 times 5. This equals 130. Now let's calculate for the last subinterval, that is 9 to 13. So here the width is 13 minus 9, and this equals 4. And then we have to consider f of 13, which is the height of the rectangle. So we consider the right endpoint. F of 13 from the table, it is 35. So let's plug in 35 here. So therefore this becomes 4 times of 35, and this equals 140. Now we have to add the areas of all the rectangles which we formed using the three subintervals. So it's basically 51 plus 130 plus 140. Let me add it up. Plus 51. So I get 321. This is the area under the curve of f of x. This is the area under the curve of f of x from x equals 1 to x equals 13. So therefore we see that this definite integral from 1 to 13 f of x dx, this is approximately equal to 321. And so we choose the option C. That's correct.